Hi guys, this is Tetsu, and today I have prepared a Phoenix tutorial, and what we will be doing is a beer simulation. This is the end result that we are after. I'll divide this tutorial in two parts, and in the first part we will start off with filling the glass with liquid. Once we have the desired detail and level, we will continue with the foam. We will take a look at how to create those nice bubbles. I'll also explain some of the parameters as we go along, and in the second part we will see how to render this using V-Ray, and we will also talk about voxel modes and gizmos and how are these helping us. Finally, I'll jump to Nuke to add the Phoenix stamp that you can see on the glass, and we will also add some background and do a few little tricks to make our render more shiny, and basically that will be it. So let's get started. Okay, so I'll start with setting up the scene units. So I'll go here to the customize, unit setup, and here under the system units I'll make sure that one unit equals 1 centimeter, and I'll also use centimeters for the display units as well. So hit OK to close that. And why is this so important? Well, because the scene scale and the steps that we're taking on each frame of our simulation are connected. And to give you an idea of that connection, I'll go here to the layer manager and unhide these two layers. And if we take a look, you can see I have a small glass and a big glass. And the small one is actually the original size of the glass, which is 20 centimeters. And you can see here I've created a simulator around it, and this simulator is somewhere around 25 centimeters high. And in this case, I'll have high dynamics inside that simulator because it's too small. And with high dynamics, you need to take more steps each frame. And with more steps each frame, you have to, of course, longer simulation times. And you can use that approach, but I find it too slow, and that's why I made the glass bigger. And as a result, my simulator is bigger, as you can see. And the dynamics inside that simulator won't be so high, and then I'll be able to take less steps on each frame, and of course that will give me a boost in the simulation times. So to recap, with small simulators you have higher dynamics and you need to take more simulation steps, and with big simulators you have less strong dynamics and you can go with less simulation steps. And we can go ahead now and continue. So I'll delete the small glass with the small simulator. So select this, press the delete button, and I'll also delete these two guys. And I've already created the simulator, but you can create one by going here to the create tab, geometry, Phoenix FD, and press the Phoenix simulator button. Then I can create the source, which is here under the helpers. Again Phoenix FD, and press the Phoenix liquid source. I'll rotate this a bit, and you can see I need to specify an emitter, and I'll go ahead now and create one. So I'll use a cylinder and change its size a bit, center it, and move it up a little to the side, and just rotate it. And I can select again the source and press the add button and pick the cylinder. You can see these lines here representing the voxel size, so they're quite big right now. I'll select the simulator, and here under the cell size I can decrease their size, and this will give me a better resolution. So I'll make them smaller, and you can see now I have a 500,000 of cells, so that will be a good starting point. And I can now press the start button, and nothing happens, of course, because we need to enable the liquids. So go into the liquids tab, press the enable button, and again press the start button. So you can see now that the liquid starts flowing, but you can also see that the liquid is being generated at on all of the faces of the emitter, and I also want it to be created here at this bottom face. So I'll just add an edit poly modifier, press the stop here, and select this bottom face, give it an ID of 1. I'll press Ctrl I to invert the selection and give all the others an ID of 2. And I can now select the source, and here under polygon ID I can say emit only from polygon ID 1, and I'll also set the mode to inject, so that I'm injecting the liquid instead of brushing it into the simulator, and press the start button again. Okay, you can see now that the liquid is being emitted only from this bottom face, and I can change the color of the liquid to something that looks more like a beer. So make this something dark. And okay, I'll switch to wireframe to see the liquid better, and I can now press the start button again. And the liquid starts flowing. There are some drops escaping. And you can see this massive amount of liquid escaping through the walls of the glass. So what most people do right now is they go here to the dynamics and start increasing the steps per frame. They say, let's say I'll set it to 6 and rerun the sim, but you'll see that this is not the reason for this behavior, and you can see these guys escaped here as well. And let's see if the bottom ones will escape again. And yes, again they start flowing here. So this is actually not a solution, and I'll switch this back to 2, and there are two things that might be causing this behavior. And the first thing that I'll check is the normals of the object. So I'll select this glass and add an edit mesh modifier on top. I'll select some polygon here and check the show normals, and you can see these normals are pointing the right direction. And if I make this a little shorter, okay, I'll select one from the inner faces, and again they're pointing the right direction. So the normals are okay, and I can now delete this. And the next thing I'll do is I'll check the width of the walls of the glass, because most likely they are too thin right now. And the general rule of thumb is that the walls of the object that you're filling with liquid should have walls that are at least 2 cells wide. So to measure the thickness, I'll just create a box. So go into the create and create a box. And for the size, I'll use the size of 1 cell. So I'll select the simulator to check the size, and here under grid you can see the cell size that we've set earlier. So it's 0.3. Copy this and paste it here. And right now this box represents 1 cell of the simulator, and let's color it red, and I'll just switch this back to gray. Okay, and I can now place it somewhere in the thinner parts of the wall. So let's say it's here, and I'll center it on the Y. So let's zoom in, and I'll press select the glass and press Alt X to switch it to transparent, and you can see right now that this wall is actually thinner than one cell, and as we said earlier, we need it to be at least 2 cells thick, so this will be our desired thickness. And to make that, I'll just select the glass, add an edit poly, and I'll select the faces, and I want to select them by angle, and I'll turn on the ignore backfacing so that I only select the outer ones, and that's perfect. And I'll just scale the walls out a bit, so I think 7 units will be enough. Let's see. So if I zoom in here again, so like this, like that, okay, and zoom in, and you can see they're almost inside, so I think that will be enough. Let's pull them to the side here and press the start to see. Select the simulator and press start, and again the liquid starts flowing. So far so good. And yes, you can see now that the liquid is staying inside the glass, so this thickness is enough. We won't need to increase it anymore. And now that we have this stable scene, we can now start tweaking the look of it. So I'll press stop here, and the first thing we need to set up is the steps per frame, because we want to have proper liquid behavior before we go any further. And right now, if I scrub the timeline, you can see that we don't have this proper behavior, because the glass gets filled in just a few frames. And I'll definitely go here and increase the steps per frame to, let's say, 4, and rerun. And another thing that you might want to do is change the advection method to forward transfer. And what forward transfer will give you is the physically accurate behavior. And you can use this to see how the whole thing should look like, and then switch back to classic and replicate this behavior. I'm not recommending using it for the final scene, however, because with forward transfer it's hard to achieve a settled liquid, and once the glass is filled to a certain level, you'll start to notice that. So I'll stick to the classic, and in just a few more frames we'll see how the whole thing looks now. So I'll wait till the 60th frame, and I'll pause this, and let's see. Okay, this is much better. The glass is being filled more evenly, not just in few frames. But I don't like the shape of the liquid. It's too flat right now. You can see the surface here. I want to have some splashing when the liquid hits the bottom here. So to achieve that, I'll just change the conservation method from symmetric to smooth, and let's start again. And the symmetric conservation is perfect for let's say an open body ocean, and let's say you have a ship passing through the ocean, and you want to have asymmetric foam patterns on the both sides of the ship. So it's the perfect conservation method for these cases. But in my case here, I want to have some irregularity, and that's why I switch to the smooth. So if I take a look again, you can see the liquid now hits the bottom, and you can see now I have this nice splashing here. But again, it's filling too fast, so I'll increase the steps per frame a little bit more, and rerun again. So I'll check this again, and okay, this is much better now. I think however I can increase it to 8 to have a even better result. And so I'll set the steps per frame to 8, and I will also increase the quality of the conservation just a little bit, 40, and I'll rerun this simulation and get back to you when it's done. Okay, and the sim is done, and it completed in only 6 minutes for 250 frames, and this is what we have so far. You can see we have the splashing at the beginning, and then the liquid travels smoothly toward the top. And remember, this is a low version of the simulation. We will increase the resolution later. But now that we have the correct steps per frame, I can adjust the level of the liquid using the source, and I can stop the emission at let's say here, to leave some room for the foam that we will be generating later. And another thing, I'll also animate the discharge in a more random way, because right now it's linear and it's quite boring. And yeah, so let's start. So select the source and press the auto key, start animating, and at frame 0 I'll leave this to 50 as the default, and at frame, let's say 200, I will stop the emission. And if we take a look at the curve right now, you can see that it's almost linear, and as I said, I want to make it more random. So we'll go here, let's say at frame 15, and decrease the discharge a bit, and then let's say frame 33, I'll set this to 80, and frame 60, 65, let's say, I'll decrease this just a bit, and at frame, let's say 135, I'll increase this quite a bit, and then at 200 it will drop down. So turn off the auto key, and I'll go in here and make the curve, set this to fast, and make it more smoother, or smoother I should say. So okay, and set this to fast as well, and okay, so you can see now that the discharge will be having this random behavior. And before I hit the start button again, I think it's time to increase the resolution. So I'll select the simulator, and here in the grid rollout, again decrease the cell size. So I will set it to, let's say, almost 2.5 million cells. And okay, so now I'll press the start button, and see you later. And I'm back, and the scene completed in 26 minutes for 240 frames, which is pretty good actually, because if you have used the smaller simulator that we've talked about at the beginning, we certainly would have increased the steps per frame quite too much, and probably here in the dynamics, instead of 8 steps per frame, we would have increased this to 14 or even more. But now we have a very nice result, and I actually did one more sim before this final one, and I did it because the glass was filling too much, and to make it feel less, I just stopped the emission earlier by just moving the last discharge key. But let me just show you the result from the first sim. So this is it, and again you can see I have this nice splashing here at the beginning, and then you can see the liquid rises a bit too much. So this was the discharge ended at frame 200, and I've just made another sim where I've ended the emission at frame 189, and you can see it's a bit lower now. Otherwise the sim is completely the same. So to show you, I'll just select the simulator, and here is the key that I've moved. So you can see right now it's at frame 189, and it was here at frame 200. So we now have this nice detail in the liquid. We have the splashing at the beginning, and we have the desired level. So we can go ahead now and start adding the foam. To add the foam, I'll select the simulator, and I'll go here to the foam tab and click the enable checkbox. And straight away I'll decrease the rate parameter, and the rate basically specifies the amount of particles that will be generated. And right now I want to create fairly low amount of particles, so I'll set this to 1. And I'll also go here to the grid section, and I'll decrease the resolution just for the foam setup. So I'll press the decrease resolution button once and then twice. Okay, and hit start. And you can see the first foam particles created here. You can also keep track of the foam particle count here in the content window, and it's updating every frame. And I'll pause here because if you take a look at the content window here again, you can see that in one frame the foam count increases too quickly, and it also creates the particles right from the beginning here. And I want to start creating the foam when the liquid hits the bottom, so I want to start the emission somewhere here. So I'll get back here to the foam tab, and I'll increase the threshold, and the threshold basically specifies where to create the bubbles. And by increasing this, I basically limit the places where the foam will be created. So let's say I'll set this to 50 and start again. Okay, so I still have these particles creating here, but I'll just wait to see the behavior when it hits the bottom, if it's still going to create too much particles. And I think that's okay now, but I'll try to set this to 70 and see if it will remove the particles at the beginning. So rerun again. And I can see here that again it creates some particles. So instead of going now and increasing the threshold to some crazy levels, I can just simply animate the rate. So I'll click the auto key here, and at frame 0 I'll set this to 0, and let's say So at frame 10, just before it hits the bottom, I will still keep this to 0, and at frame 11, when it hits the bottom, I'll set this to something higher now, because I've made it I've increased the threshold, so I'll set this to 10 and open up the curve editor, and I'll set this to the keys to stepped. Okay, and press the start button again. And now I don't have these particles that were creating here at the beginning. And now the liquid hits the bottom, and you can see the foam starts creating. So I'll let this simulate for a couple of frames, and I'll see you back. So I paused this, and I rendered a frame to check the size of the bubbles, and this is the frame that I rendered. And you can see I have enormous bubbles like this one here, and also the base size of the particles is a little too much. So I'll just close this and select the simulator, and here under the foam I'll just decrease their base size to, let's say, 2 millimeters, and I'll go ahead here and increase the resolution back. So press the increase button twice, and now I'll start this and let it sim through, and see you then. And the sim completed, and we're almost there. We have this nice foam at the top, but to make it reach the end of the glass, like in the video that I showed you in the beginning, like here, we will need more particles and higher lifespan. So I'll definitely increase the rate and the half-life. And this is what we have so far. There are still things that we need to take care of, and one of the first things that I did is I rendered another image to check the size of the bubbles. And if I just close this and open up the rendered image, you can see I still have bubbles like this one that are getting quite too big, and I'll decrease their size, and I can just slightly increase the size of these base bubbles here. So let me just go here to the foam tab and start putting in the new values. So as I said, I want to emit more particles, so I'll increase the rate here, and to increase it I'll just open the curve editor and select this key, which is the key at frame 11, and just set this to 50. Okay, close this, and I'll also increase the lifespan, because you can see that these bubbles, when they reach the top, almost all of them are dying, and that's why the volume here stays low. And you can also see here at the top they start to shrink because the particles start to die, and we want to keep them there longer, so I'll just increase this really high. And let's get back to the size. So as I said, I'll just increase the size of the base bubbles, and I'll do this by increasing the size here. So I'll just slightly increase this, and these bubbles that stand out here, I'll just decrease their size by decreasing the variation up. And the variation up basically specifies how much bigger than the base size a bubble can get. So I'll just drop this down, and I also want to introduce bubbles that will be smaller than the base ones. So this is what the variation down will do. So I'll set this to 10 because I want to have particles that are much smaller than the base ones, and this is what the variation down does. And another thing the variation down will help me with is if I open up this video again, you can see here at the end the bubbles are rising with relatively same speed, and they travel like in a group. And this is because they have they all have the same size, and therefore they rise with the same speed. And the variation down will introduce smaller particles which will be rising slower, and I'll have a smoother rising at the end here. Okay, and the last parameter in the size section here is the distribution. And this distribution gives you the ratio between the base-sized bubbles and the big ones. So by making this value higher, I'm basically telling Phoenix to create more base-sized bubbles than the big ones. So at the end, I'll have less of those big guys here. And I will increase the rise speed because I now introduced a lot of small bubbles, and they will rise slower, and they might never reach the top here before the end of the animation. And to make sure that they will, I will just increase the rise speed, so I'll set this to 55. And another thing that I'll increase is the bubble-to-bubble interaction. And what bubble-to-bubble gives you is when you have two bubbles that intersect with one another, they will stick, and by increasing this, you force them to stay together instead of breaking up over the time. So I'll set just a little higher, and I think we're almost done. And you can also export the velocity channel if you want to motion blur those bubbles later. And we will leave the patterns for now. We won't need them as they will be more appropriate for ocean simulations. So I can just go ahead here and press the start button and see you back. And this is the final sim, and I actually rerun this sim one more time because I was not having enough particles to make the rising at the top. So I've gone here to the rate and I increase it to 68. So I've jumped to the curve editor and made this from 50 to 68. And that's the key at frame 11 when we start the emission. And I've also rendered another image to check the size of the bubbles. So if I open up this image, you can see now I have bubbles like this at the top here that are bigger. I have very small ones, and I have the medium ones, which is the base size bubbles. And I have this nice variation now. And if I open up the comparison between the final result and the simulation from the previous video, I'll play this back. And at the end you'll be able to see how the rising is much smoother now. And this is the rising. You can see the particles are not traveling in a group anymore because we have small ones that are rising slower, and medium ones that are rising a little faster, and the big ones that are rising very fast. And I think we're now ready to start rendering this, but before that I just want to organize my scene very quickly. So I'll just select the glass, and I'll rename this modifier that we used to make our wall sticker. I'll just rename this simulation because that is what I used it for. And I'll also give the emitter a proper name, and I'll open up the layer manager and select all the Phoenix stuff and put it in a new layer called Phoenix. And I will select these two guys that we used to measure the thickness of the walls, and I'll just delete them because we won't need them anymore. And lastly, I'll just color code these two guys to blue so that I recognize their Phoenix objects. And see you in the rendering part.